Let's take a look at describing distributions of graphs and data using shape center spread. We'll also take a look at IQR, which is the interquartile range, and outliers. So our first example, Stanley All-Star played hockey for a total of 15 seasons. He recorded the number of points, which is goals plus assists, he had each season. After looking at the data, Mr. Burke sees a number 49 and he exclaims that's way too high. That isn't normal, and then accuses Stanley All-Star of cheating and taking steroids. How can Mr. Burke prove this situation? So by punching all the data into the calculator and making a box and whisker plot, this is what I come up with. Notice 5 important things: minimum, quartile 1, median, third quartile, and maximum. To help Mr. Burke see if 49 is cheating, he wants to determine if it is an outlier, meaning that data point of 49 does not fit in with the rest. To do that, I will find the interquartile range and test if it's outside my data. To do that, we will be looking at this equation down here. So the interquartile range is Q3 minus Q1. What that's telling you to do is to focus on this part right here. So Q3 minus Q1 is the same as 28 minus 20, which gives you 8. Then statisticians have figured out that you multiply that by 1.5. So if I multiply 8 by 1.5, I end up getting 12. So this 12 is going to be critical for us. What we are going to do now is take this 12 and we will subtract 12 off of Q1 and add 12 to Q3. If I subtract 12 from Q1, I get 8. That means my minimum value should be around 8. And notice that my minimum is actually 12, so that's good. Anything outside this value of 8, so anything to the left of this 8 would be considered an outlier. So if I do the 28 plus 12, that will give me 40. So let me go to 40 on my graph, and 40 is right there. So anything to the right of 40 is going to be an outlier. And if you take a look, our maximum is 49. Therefore, 49 is an outlier. And Mr. Burke does have some statistical proof that Stanley All-Star could have been cheating. Let's take a look at describing a shape. When we describe shapes, we like to use ly words. We never say the shape is normal, the shape is skewed left, the shape no, it's approximately, slightly, it is almostly. It just, the ly words are kind of vital to us. So we're going to look at 4 different ways. Here's the first one, and if you notice, this is, if you look at that shape, that is skewed left. This is skewed left. And you could remember this because if you're on top of here and you're skiing, which way are you going to go? Now, I guess a daredevil goes right, but it's probably for Mr. Burke, it's safer to go left because more data is on the left side. So skewed left is one way to describe. And you guys could probably guess that this will be skewed right. It's probably better to ski in this direction for my own safety. And notice most of the data is on the right side. So skewed left, skewed right. This isn't really skewed anyway, so what we actually call this, we call this a normal distribution because it looks as if 50% of my data is to the right and 50% of my data is to the left. So this is called a normal distribution. The last type of shape we'll look at notice this has two peaks, and this is called a bimodal distribution. So you got four choices: slightly skewed left, slightly skewed right, approximately normal, approximately bimodal. And then describing the center, you're actually going to have three things. You're going to have mode, mean, and median. Well, remember we discussed mode is not very good because we really only use that for categorical data. So I'm going to get rid of that. Mean is a good way to describe the center if the data is approximately normal. Because remember, a mean is not resistant to outliers. So if you think of that Stanley All-Star example, I would not use the mean because it had an outlier at 49. And the median, this is a good way because it is resistant to outliers. And then how to describe the spread of the distribution. There's three different ways we could do this. The first is IQR, which you guys just learned, which is Q3 minus Q1, and this is your interquartile range. So that's the first thing you could do to describe the spread. The second thing you could talk about is you could talk about the range. And when you talk about the range, usually you talk about the minimum values and the maximum values. And the last one we're going to learn is standard deviation. And just real briefly on standard deviation, which we'll learn more about, that talks about it literally just talks about the spread of the data. How spread out is the data? Is the data group closely? Do we have a lot of data swinging on the left side, the right side? And that's standard deviation. And with that, you should be able to describe the shape, center spread, talk about outliers and IQR.